Welcome to the second part of our lecture 13, OpenStack Cloud Operating System. And we learned in the first part really a lot of building blocks, which are reassembling or basically having the same functionality that we see in public cloud providers, something like the AWS S3. We have seen basically the compute entities, even containers are supported, which are similar like EC2, for instance, particularly in the light of the fact that what we want to have from a cloud is this scaling capability. And of course, in a way, you want to have this auto-scaling, right? You don't really want to sit there manually as a developer and look on the load on your servers and then react. So that's not what developers do. And of course, here now you have these metrics, and that's why we were reviewing them. And you will look at them from time to time if your server landscape is doing the right thing. And of course, then you have to react. But let's say lots of these things should be done automatically. If I need more workers, then there must be something inherent in the design that I need and can then get more workers. And these kind of things, which would be now the MapReduce example, we will come back to a little bit. But also then looking at Blizzard, right? If you have millions, over millions players in your infrastructure, you don't know if they just always play at night, if there's some specific happenings in the different countries, maybe a public holiday where people tend to do and play much more than in other countries. You have constantly an interesting load you have to look at. And on this scale, you really cannot do that manually anymore. So you need certain technologies which are really able to do this auto-scaling. And that's why we basically, in the second part now here, in this lecture 13, we not go again and go through all the different services, because you have learned the key services already now in the beginning. Now, the interesting thing is really firstly to think about that these things work together. So essentially, you can combine them extremely nicely. And with this, you have, of course, a powerful software directly at hand that otherwise to redevelop would cost, lots of millions of dollars probably to do it in a scalable fashion and production stability. And then, of course, on the other hand, you will see how people now tune that to different adoptions, to different scenarios, like Blizzard games, for instance. Right, so let's look on a certain different capabilities, what OpenStack has also to offer, especially in the light of the fact, if you look that essentially we want to use that all together. And this is a good example when I come later to the idea of thinking about so-called blueprints, pre-installed blueprints that you can just download and then deploy, right? So let it be a web application, an application for big data that actually incorporates then this master worker design we talked in MapReduce, or an e-commerce platform. So all of these are basically already given. And all of them have already in common what is the key strategy of OpenStack, of course, which is use all of these different services together. Not all of them at the same time, but of course, they are tuned for each other. Here we see a typical scenario, maybe with a web application using here this load balancing, a little bit orchestration with heat. But the first of all we want to have is, of course, some Nova service, maybe some computing, as we have seen and learned. This is around a VM. A VM needs to have an image somewhere. So that's what we get essentially via the glance service. And we can store these images, of course, somewhere. We need real storage, right? So this is just a service managing it. We need actually somewhere to store it, the storage, and we learned we can use a Swift object storage for it. So in a way, we have also then maybe backup volumes that we can do if we want, using this other service we learned, the Cinder. We can have certain other services which you didn't really have, which is not so important here right now. It's the databases related, where you then basically register certain images that you want to use. But quickly you come to the point that each of these different building blocks has a specific purpose. Especially thinking about network security, Neutron is a very key service. When you think about it, it should be all very safe and secure and reachable, of course, within either the intranet, if you have a public cloud, a private cloud, or of course also from the public or you have some that are called DMZs that you create, like demilitarized zones in networks that have partly an internet, an interim part, an intranet, so to speak, and then also a public part. So, and you have basically lots of different options to look at from the top, which means that's the user-facing side. You would have a horizon UI that you can use nicely and can configure what of the services information from all the setup here you basically give out. Or, as we will see in one of the parts later, Keystone, which is about then the authentication, right? So are you the right user that is able to access this? Do you have an account? These sort of things. Of course, it's also valuable to you. Then when we thought about the metrics, we have to shift the view now, right? It's our cloud. So we have to think a bit of monitoring that metrics and these kind of things. So monitoring that these services are up and running for the users, whatever it is, this upload and download service maybe of this Nordic Light photos we discussed once. So you have to make sure it's your responsibility now. You cannot just ring Amazon and say, my image is down, or there's some error and you use an email. Now it's your responsibility. So you need tools at the hand to also look essentially on all your orchestrated services here and see if everything is in order. And you can imagine that this needs to be done in a way, really in a semi-automatic fashion, right? So coming to another example, what we had already basically in the last lecture, but also we came back to this in the beginning, where we said we learned a lot that Kubernetes is really nice. It's built on Docker, which in turn is also nice because it gives us containerized applications. But if we have a containerized application alone, that would be not really useful. We need some managing entity, right? Which is then this Kubernetes tool, which really helps the orchestration of all of this. And the interesting thing with OpenStack is also it supports this kind of third-party service directly. So we basically can deploy with Kubernetes on OpenStack and with OpenStack, which is a very nice idea now if you think about on the left, this UberCloud example again, which really prominently shows us here the giants, right? The Amazon Web Services, the Google Clouds, and so on. But what if you have your own OpenStack, in your company or startup, and actually you can just shift these, if they're Kubernetes compliant, to your own infrastructure. Not forgetting, of course, that you need to have some hardware underneath, right? This bare metal needs to be somewhere there to be operated with virtual machines or containers. It doesn't matter, but you need some hardware. OpenStack is, of course, software and doesn't throw you hardware in the cellar, but it gives you at least or removes the burden of having software developed for it, because that's really what you get from OpenStack. And by being Kubernetes compliant, you see here the migration that you can actually do nice quickly, which is not one way. Of course, if you do everything in your private cloud in a way towards Kubernetes, then you can also easier go back to the giants, right? In terms of peak times, maybe when you need more computing power for a startup that maybe has an app, and at Christmas or so, there's a specific part in the app which would be unlocked that, customers will just, use it by orders of magnitudes, and you really want to have something hugely scalable and can do so by bridging out. Of course, you have seen you can do this also with APIs. So there the question is where you draw the line. Do you want to have your direct instance there, or you use different instances and you put, let's say, an S3 interface for an example just to access some storage there? These always go together, so you would have different ways of how to combining it. So when you come to OpenStack, one of the interesting things I would like to highlight now in the second part is really this blueprint nature. And by blueprint, I mean certain configurations which are already in a sort of manifest described of when you want to do a web application that you see here on the right left-hand side. Where do you have to think about? Now, one, you have to think about the load balancer, right? How many hits of the users will be your upload and download service, for instance. Then you have surely some security. You have some interesting way of thinking about there should be some people accessing it, some people not accessing it. And of course, you want to have here in Neutron also sort of network security along the way. And there's, of course, an idea that when you want to have, let's say, this upload and download server, you kind of want to also have volumes to it, so kind of storage. And then also to think about replication schemes maybe that we learned in MapReduce, for instance, as just an example that once the people have uploaded something, it is for sure replicated and never really, lost again. These are just, of course, examples, right? But this blueprint enables you to just download all of this, and you have already all the instances as software available as well, so that you essentially just have to do some configuration parameters and tune it to your needs. Again, think about, of course, you need some compute and storage alone here to make that work, of course. So meaning then assigning with Neutron the right IP addresses to the right hardware, but essentially you don't have to think anymore, oh, can I actually load balance with my many users, things like that. And the same is true for lots of different application areas, which are kind of common throughout the world of problems in the internet. Content delivery networks like Netflix, right? A big thing, video processing. I had that 2 years ago as an example. So if you want to use that, please look at those. This time I included Blizzard because I thought it's a bit more popular these days. So containers, of course. I put in also e-commerce because we will look at eBay a little bit, how they do it. And you see basically for all the different problems you have, big data here, which we look more into detail when we have to have this master worker node, if you remember from lecture 5, right? In previous times, maybe master slave, but should not be used anymore. So it's master worker, where we had this different name node and then the data nodes around. You essentially have all the blueprints here, which are already also validated. That's the interesting thing. They are coming directly from real world reference architectures, right? Which people use in production. So they can point to things that really work. And they just say, we use this configuration here, use it for your own sake. And as it is based all on open source software, you can essentially run the same as eBay or essentially as Blizzard at your own premises. Of course, think about the hardware underneath that you still have to buy, but of course it helps you with, have no software investments whatsoever, except just the configuration that you of course have to do. And of course, in a way, automatically with this, you become an OpenStack expert. But you will see also, if you take the time, what I would recommend to see the Blizzard video, I think it's really eye-opening, where an OpenStack developer from Blizzard even really admits that he doesn't know about one of the other services from OpenStack because it's such a huge landscape that it's hard to keep the overview, especially in this, top 3 in terms of open source software development. I mean, there are commits daily, numerous times. There are new services all over the place, new ideas. And it's such a lively project that chances are you are having, it understood in that form what this area, let's say compute in this area is all supported by OpenStack. The next day, there will be another service that interfaces with some other, let's say, functionality. So, but let's come back a little bit here to the different technologies. Why it's interesting for us to look at this in a big data course, because essentially OpenStack can help you to really cope with this big data load. Let's assume again we would have this Hadoop cluster that you already know by heart now, the MapReduce paradigm, if you remember, which has essentially all these different worker nodes that map certain things depending on the key structure you have, and then on the key value pairs, and then another set of workers which do the reduce tasks, right? And of course, somewhere needs to be the framework, which is essentially here grouping all the keys automatically. So when we come back to this case, we have there 2 things. One is that I don't want to deploy all of that manually, right, on all the different nodes. Let's just say I would have 50 worker nodes. I don't want to do this manually and install here, let's say, the MapReduce engine on that. I want to have something that automatically deploys it. And secondly, I want it able to scale. So if I have a small data problem, I won't maybe just have 5 workers involved. But if I come with 200 terabytes of data, I want to have 20 workers involved. So the scaling, again, is, of course, a key issue here we have to talk about. Another example that we had in one of the lectures just recently was essentially FP growth. You remember this was for shopping basket analysis, transaction data that we looked at with frequent patterns to be identified, and we had different versions on it. One was a priori, that in a way didn't really scale because of the inherent nature of the algorithm. But in a tree-based setup that is actually this frequent pattern tree here in FP growth, we have a possibility to parallelize this. And it would take a whole lecture to explain why and how. Just take for granted that there is already an implementation in Spark, and that's what you know already from lecture 3, the machine learning library, which has a parallel version of this FP growth actually included. So if you do and want to scale out now and say you want to have, as you heard from the kind of data we have in a real production setup in lecture 11, right? We deal with 2-3 gigabytes of data, which are then needs to be put in memory, needs to be more parallelized all over the cluster, where FP growth then really scales. There you can use this library in Spark, and it just will go very similar like we have seen with the MapReduce paradigm all over the cluster, using the strategy we use with the master and slave. So take it here, that should be master worker essentially. So you would still have to deploy 1 or 2 as a failover, maybe 2 of these name nodes. If you remember, they carry the metadata to see where is which data of the transactions of the data of that we have from the retail shop. And we'll do a little bit this resource managing as well, right? The yarn, if you remember from Hadoop. So which is actually occupied, which node, which already does some data processing, and which node is idle and can, use some work. And then we learned that there's this scalable worker element. So here we could have 5, we could have 10, we could have 100 workers. Of course, here you come now to the limits of the capacity, right, of your real hardware. Even if you have just one, let's say, small core setup of 6 or 12 cores, and then want to deploy their virtual CPUs in terms of hundreds or 200s, then you probably run into trouble because it's so much always switching between these different virtual CPUs that it doesn't make sense. Of course, here you have to think a little bit to see how the kind of load is and how you actually support this by hardware. The software alone doesn't give you scalability alone as such. You need to have the real pizza boxes here, or the kind of cores, which are always in my lectures a little bit illustrated with this, where you see then what the load is and that it really scales. And these are 2 perfect examples for an OpenStack. So whether it's Spark or it's basically coming back to Hadoop, you would use essentially now what you have in terms of OpenStack. And there are different servers, which of course, different services, which knows you this functionality you need. You can have a Nova compute, which essentially takes over the scheduling, the resource management, right, to allocate resources. What are the free ones? So you put in this Nova manager essentially now the head node, as it is sometimes also called, or the master node. And then you have many name nodes here, 1 or 2 to have failover, right? Because if this one goes down, your whole cluster goes down. So sometimes people have a secondary name node to prevent that from happening. But this is something what you can do nicely with Nova, and of course needs also a little bit of data for having, to know a bit about the metadata. So where is what in terms of the Hadoop or of the Spark installation here. And the node manager and so on, it continues, of course, needs to be Nova. This is a, let's say, small part that is communicating, of course, with the resource manager. Also there, you need someone in a specific way doing some tasks. So it's good to use Nova for this. And of course, then in the end, this data node that you put on the same node, saying that here is really where we process where the analytics is really happening. So this is something where then the scalability comes in at this point in time at these kind of level where we maybe want to scale up and down. And this in a, let's say, automated fashion. And this brings us to different frameworks, really. You can imagine a very popular framework like Hadoop, like Apache Spark has different ways how you can do the scaling, how you can deploy it via OpenStack. One good example are those which are already pre-configured from Apache Ambari. So this is an open source project essentially that is all about simplification of Hadoop management, so that you have not only, let's say, a much easier control of how many workers there are. You remember here in this cluster you want to scale up, remove nodes, add nodes quickly depending on your node, hopefully in a semi-automatic fashion. You want to have a control interface, so some UI that tells you what's going on. And also then, of course, this head node, name node that is already kind of pre-configured as a blueprint. And when you use this, it has also lots of API interfaces for REST. But I think one of the interesting things coming back to the start of the lecture is, particularly in this setup, what I found interesting, it has lots of views and, let's say, analytics, graphs, and queries. How good is your server running? If you remember, we said we're switching the roles here, right? You're not anymore a user of AWS, you become someone like AWS. Of course, probably on a smaller scale, but that means you have to have your clusters in order. You have to know the metrics of the services. Are they delivering? Are the Hadoop daemons, basically the small ones that are running on all the different nodes, are they really active to get some data? Is the Yarn application, you remember, the resource manager really working? What is the timeline on the jobs? Is it full? Is it basically 50% utilized, or can we have more? You see quickly lots of different metrics needs to be aggregated, and in a way you need this in real time. So here you see again the NoSQL store we talked about, optimize for read, right? If you remember the lecture where we had HBase. So, and this is fueling a lot of interesting views that you in a way need if you want to, let's say, sell your MapReduce cluster to the outside world, or you use it to annotate maybe your Nordic Lights picture upload download server, right? This is quickly what you can do is, employing here and there some machine learning algorithms, but then you're responsible, if you're charging for this, that it also works nicely. And I think this is not to be stressed enough. And the other end, you are also responsible for the security breaches, right? Also think about this, and this has quite some implication also if your startup or your company will survive. You heard that, companies like Garmin have been hacked from hackers and then want a big lump sum. Garmin is big enough to survive this from the reputation, although all customer data was actually away, and that means someone has it, all your personal data. But in the sense, this could be your company, and then you have to think about survival, right? When you're in the media and suddenly being hacked everywhere. So this is a very important concern, and that's why also OpenStack, coming back now to this technology, allows you lots of different options of how to really secure your internet. And in one of the assignments, you have really seen that creating key pairs in the right area in Amazon. These sorts of things are extremely incredibly important also for Amazon to not mess up. And of course here, when you are doing the OpenStack installation, it's your responsibility to do so. And the good thing is you get really good at hand, not only all the software that is doing it, you also get the blueprint, how you actually assign it to different nodes, because the different nodes needs to be, of course, differently configured. Some are facing the outside world, perhaps, right? Especially the head nodes here. They need a different security setup than your worker nodes and things like that. Usually it goes to a technology which is these days software-defined networking, which is a key element in this. So it's not anymore so hard integrated as maybe 10 years ago with routers and so on. Here it is much more like kind of network as a service layer that is put on top. But also this would require a complete course lecture to go into details, but it offers you lots of possibilities that you also probably have already explored in the AWS. When you're doing it in a way, you can do very similar things here in having different security groups for different users and so on for different instances defined. So both these topics are incredibly important, right? When you shift the view, metrics and security, and of course, this is your responsibility. Now, when we think about clients, it's a little bit, let's say, less dramatic when I think about metrics and the security. Here, it's about the developer perspective. If you want to, let's say, user services with the outside world, with different REST interfaces, for instance, with different programming languages, want to implement something. I guess this goes a little bit without saying that this is supported. You have lots of different APIs actually already inside, and it's just a nice environment because, of course, it's now linked to all the different services that you have as an API, right? Think about the jungle of services, so to speak, that we had in the beginning. You have very powerful MPI, what you can do a lot, and an SDK, which is really strong also to basically on top of those services, create your own unique selling proposition software. Let it be the upload download software, whatever it is, what we discussed with the Nordic Lights, but could be anything else. And if you think how powerful that would be if you have now a content delivery network and use a blueprint for that, right? You can start maybe thinking about moving from just file uploads of pictures from the Nordic Lights to movies about Nordic Lights. Just as an example, again, as a unique selling proposition, because then you are much more in the level of, content delivery networks to scale differently than just file upload, file downloads. So, but I think this is just then the move, and you essentially can take the SDK parts with you and deploy another OpenStack cloud essentially underneath it, still keeping parts of your unique selling proposition software still intact, right? Of course, videos are different than files. You can imagine this, but the scaling of the infrastructure still goes along with it. Here's a good example where you can also get more incentives of moving to this. Firstly, because it has already lots of public clouds that offer functionality based on OpenStack, and has also validation schemes to really be trusted. Here's a very good example for Europe, where they have certain certifications also to be a very trusted entity in Europe. If you remember the Patriot Act we discussed, right? So this is a European cloud. Then if you put this in, you can be sure that people don't, in US, let's say through the Patriot Act, cannot access the data, that it's GDPR compliant, that lots of different aspects which are now more going again to this legal area. So, and you see that really T-Systems is a very big player, and also they rely on OpenStack. It tells, again, the same story. It's really adopted everywhere these days. But you get also interesting, let's say, appliances that you can reuse, right? Let's say you're a company, you built on VMware the last 10 years. So you have VMware experts, they're certified against VMware solutions. But now everywhere said people, you have to move to the cloud. There are much better scaling possibilities. So why not you build a cloud on top of all your VM devices? And now instead of tuning all of this, let's say, cold building blocks that you would get from OpenStack, you can also have here already a pre-set up appliance that works nicely together with VMware solutions. And I'm neither paid by Dilicom or VMware. It's just examples, really. If you go to the catalog, you will see lots of different players in the field. And of course, you can save considerable time of doing so, of just using these different, let's say, integrated OpenStacks. And of course, the marketplace, market, the name already suggests, it's of course also now a business opportunity. You can add your specific, let's say, service that you build on top of OpenStack and bring it into the marketplace, and let's say get revenues even if you have an attractive, let's say, on top service on OpenStack, or a very interesting setup of using all of these OpenStack parts together. And the foundation that is behind OpenStack would even support you with visibility on the website and so on. Right. By now, it is even in a way something I will allude to in our epilogue. And you see this a little bit here on Red Hat and EBM. It is a job creator. What I mean by this, I mean, today you would find lots of job opportunities. If you know OpenStack, you will find lots of job opportunities. And we will see this in the epilogue when we talk a bit about your future possibilities in the academic sector, but also in business. So OpenStack developers that know these services by heart, these are really needed, and they earn quite a lot. It's not only machine learners, right? So it's also these people that really have the underneath cloud setup under control. In particularly, I think a very sensitive one is network security. This usually pays very highly if you're an expert in this and know how to do it and well configure it in the cloud setup. And you see here that, of course, consulting on this on top is even done by the big players like Red Hat or IBM, but also smaller players can already get considerable revenue by really do consulting for OpenStack. And you see, this has really created a large market in the cloud place for different areas. Perhaps training is another one where, you not only have university courses, you have also certain trainings where you get certification of being, OpenStack or being, an OpenStack developer or being a different, let's say, on top solutions certified developer. By meaning, of course, you could do this on top of some companies like in AWS again, or on several different other big players which offer these kind of more or less career tracks, but as trainings that you can buy on the internet. And once you graduate from them, you get the certification, which could be something you actually can put on your CV. But more on this in the epilogue when we summarize everything next Thursday, what we learned. Let's come a little bit more to some industry examples. And by now you can imagine if large entities are using it, also eBay is using it. And also what you see here is it is nicely that you can combine different regions. So it needs not to be, again, on one premise, right? So there are lots of different elements inside the OpenStack, which is nicely shown by eBay, that you can go over different regions to use all the different services. But in a way, what they then inherently use is nothing else than having, Swift. You remember that was an object store, which is quite prominent here. But also things like the dashboard to see the information, Keystone we already discussed. So you see essentially that all the big companies these days in one way or another are almost related to OpenStack. And the question is, if a company doesn't do it yet, why they don't do it, right? So especially if they have scalability issues. Of course, not every software has such a high amount of users. Think about eBay every day in terms of users. This is, of course, something where you would say it's quite much. But now the other way around, think about Walmart. It's retail, right? So here's, retailing comparison. Maybe they do FP growth every night, right? To understand the customer better and things like that. So they need an infrastructure that scales as well. But why? And they have a different setup of different shops, right? They have a massive amount of shops, and they want to analyze basically all of these different data from all these retail shops in different regions. So running regional models, the shopping behavior in one region, in one state of US might be completely different from another region. Still, the setup of how you do the cloud setup remains the same. You need the same services, right? Nova and things like that. And yeah, so in a way, that's really an interesting example. And remember that this e-commerce had already a blueprint, right? So we can just download a blueprint there and basically see that has been approved by eBay. This has been approved by very big companies. So it would probably also work if you do use it for your website or for your business. And this is, of course, a very interesting thing that you directly learn from all the years of experience from eBay, right? They do this many years now. You will see Blizzard is using OpenStack since 2012. So that's almost 10 years, 8 years to really have experience in using this software in a massive scale. So in this sense, you have also software technologies which are really production stable, right? Which is a very important consideration when you think about open source software. It is lots of flexibility along the way. So we talked about the dashboards, but also the APIs. You're still not bound by OpenStack, right? You still can use the APIs to maybe then scale out to EC2 at some point in time when you have peaks, right? And these peaks, of course, are loaded for us. We know that if it's our own software and we deploy it on our own hardware, we're limited. But if you really with an API can quickly go to the hardware of Amazon or MS Azure and so on, then of course you have a chance that you're really ready for the peak of your usage, whatever it is. Is it an app or a simple website or an e-commerce platform? And that brings us to the Blizzard entertainment example, which again, I think some of you probably will know. It's quite famous in the gamers industry. You see really an OpenStack driver. They're using it as a private cloud to host their game servers. already since 2012. And of course, you can imagine in 8 years, this company learns a lot and also changes a lot. So going over the years between all the different games they had, I mean, starting from World of Warcraft, which was one of the big ones, some of you may know, until today, which is Overwatch maybe. These are things where you learn from one game up to the next, and then you learn where OpenStack has limits. So you probably think about OpenStack, you contribute to the development, and then you have better services, which is nicely explained, I think, here. And I encourage you to look at this video. So I think it's really interesting, not only because it's gaming, it also shows you how they flow with the time, right? They were probably on the AWS services in May 2009 and realized that costs a lot of money, right? So why not doing this basically on premise and create a private cloud, right? So they still buy the hardware, but they have it under control in their game servers, and they need some auto-scaling resource. And there's a certain service called Heat, but that was not good enough. What you will learn in the video, and then you go to another service called Zenlin, which is a little bit interesting. We will also have a look in it, how it works. But this shows you that over time, they of course use different services in the cloud, learning from experiences. And if there's some service maybe just good enough for one section of the business, it doesn't mean that it's maybe better for the other. So we have to create something new. And that's how essentially OpenStack actually developed over all the years. So you will see Sahara was beta. These all were beta at some point because they weren't the core services like those. Zin came to it. So in the beginning, nobody thought directly about containers. It was only virtual machines. So you see essentially really developing, but not just for the software point of view, also from the experience from the big companies. And Blizzard is a very good example on that. And it also shows you with this game, I think, very nicely why they need this technology, auto-scaling, because you see when you have this interesting game here, Overwatch is a person shooter. I have to admit, I never played it, but you see the numbers here, 40 million registered players globally. So this, of course, gives you an indicator that this is something where administrators not really anymore can look on the numbers and, you know, do their nights and day in front of the screen and say, oh, we have to change this server or that server. You need something which is, you know, automatically scaling depending on the load that you have, and use idle capacity for one game than for another game. Because if you remember, Blizzard is not doing just Overwatch. They still have World of Warcraft and many other games. So this auto-scaling now is, as you see, still very tricky technically. So you can have, again, 2-3 university lectures talking about all the problems of predicting load versus the problematics of suddenly peaks and so on. So it's lots of interesting technology, but you see here a very good example that sheds lights what I mean with this. So we would say without auto-scaling, you kind of fix to the setup that your game, let's say it's game A, right? It is loading in all these different VMs here, and it's stuck there. It's actually just fixed there, but it could take more load. But we hard-coded it in a way to the scaling of always using all the nodes, even if parts of all of these are idle, right? Because it can digest maybe 1 or 2, 3 loads more. Now, when you have auto-scaling, you can come to a situation of saying, of realizing this, that we basically assigned this 4 VMs for some certain reason. There was a big peak, or there was a convention maybe about games, a gaming convention, and then many people use these games, also at the booth of all these different vendors which are there. But then essentially suddenly it drops significantly, and this game essentially doesn't need this capacity anymore, right? So in a sense, you have available capacity that you block if you don't auto-scale. But if you have this auto-scaling intact, you see quickly here you have now free capacity, and what they do in production then, and in a really basically automatic fashion by using the OpenStack components, Zenlin mostly, to really reallocate then this space to use it just for game B, because now it's required perhaps from this particular game. So you reuse again your hardware. The same idea we had in virtualization, of course, but if you have just plain virtualization, you have much more your own control on it. You need to really steer how many VMs you have. You need some entity on top, like now you have with OpenStack, essentially here as an example, an autoscaler that is going with the orchestration, is, in a way, killing VMs and restarting VMs as needed. And this is really the example I wanted to leave here at the end at the table for you, right? It's thinking about all this different load that you see here, up, down, depending on different elements. And then, of course, how much you deploy up to the maximum size of the cluster, perhaps, and so on. And what essentially the service is doing for you, right? With the auto-scaling service, you can scale up with it. It's always looking at the load automatically, right, on your game service with your game cluster. And then when it looks like this, there's a service which then can decide, okay, the load is kind of fishy. Let's create a new VM. You use automatically the interfaces that you have in OpenStack via the Nova service, which gives you the VM, and to automatically deploy another game service and actually to distribute the load. And this requires not really administrators sitting anymore in front of this. So you can configure this wisely that, for instance, at 80% of the load you start, or maybe you see the thresholds here at different levels. When a load is already observed to a certain degree of all your resources, then you start the auto scaling. And of course, you can imagine it's the other way around as well. So when you see the game is, let's say, extremely loaded, and suddenly there's something happening that one of the servers is really not really anymore needed, then you're saying essentially can do something like this life cycle watch or life cycle hook here, to say that essentially it's not anymore needed. We should trigger something. And this trigger then can activate, which is a little bit more elaborate than the scale up, then that the Zenlin service is auto scaling identity essentially again can basically delete Nova instance, which in turn, of course, means you delete here the game server, which is based on a VM. And this just works beautifully, and of course scales horizontally very nicely. It's production stable software that shows basically that you really can use it in practice if you really need it, and can you now use it for your startup. At the end of the lecture, let us just review a little bit what scientists were doing, right? And what you are doing in the assignment indirectly, because you use OpenStack in the assignment without really knowing, basically, right? To pull up the cluster of the HDF cloud. In one of the lectures, we also talked about this public cloud EOSC, so which has lots of interesting services, if you remember. And one of these interesting services was this Dropbox, right, for services. And as part essentially of your assignment, you already, or some of you already have now asked for an account. So you got already an account on the HDF cloud, indirectly using, of course, one of the OpenStack services already, which is about identifying authentication. And we see that a little bit when we look now behind the HDF cloud. Just remind ourselves also about what was the other EOSC public service we kind of combine with the private service we want to build in Helmholtz. So let's look a little bit on this. What is Helmholtz? You want to know maybe just shortly. Or some of you know, I'm coming from this Uli Supercomputing Center in the past, being 15 years here. But it was just one center out of many, many, many different ones all over Germany that all together are the Helmholtz Association. And they needed a cloud. So basically a private cloud, which still can access public clouds, like, for instance, a B2 drop from EOSC, right, which is out there. So this is a perfect example of an organization. Now, this is, of course, in academics, but could be also in business. And what's happening is that we just use all the same components you have seen at Blizzard. The Nova Compute, the keystone for the identity. Once you log in with UDOR, and you basically be introduced in something it's called LDAP, an account system, basically with your account. And then you basically can use indirectly these OpenStack deployed services, really with your identity via UDOR. And you see here also the link. When you log in once into the system, you see B2Drop as the EOS service, which is in the public. You see the HPC mount. I will talk about this a bit more now in this. HPC mount means you can now go from a HDF cloud, which is not really a supercomputer, not really a big cluster. We talked about more VMs, but via the data, you have a direct link to the big machines here, UDAC, basically the login nodes of different large supercomputers via the file systems here, and certain NFS mounts, which we will allude to much more in the high performance course, which is a bit complementary, and then focus much more on the technicalities. But it is an excellent way of showing you how you can combine now cloud with high performance computing systems, and actually how to also use OpenStack for it. And it's interesting to think about that all of that, what you see there, is essentially OpenStack services that are deployed in Docker containers again. So this is an interesting aha effect. So indirectly, again, we have our containers. We use OpenStack to create our own HDF private cloud, essentially to contact also here the public cloud. So, and that's, I think, it. I could talk ages about OpenStack, but I think that's not the learning that you have here in the course. We do, however, have covered most of the territory, which is essential in cloud computing. There are many niches we could go into, and many, let's say, larger topics which are related, like streaming. We will look into next week, or graph databases gain incredibly popularity these days. But that's all for today. Just some of the references here.